Now, let me show you the constants first, then I will show you the serially reusable property. Now, let's open up our package. To make a variable constant, the only thing that we need to do is writing constant keyword right after the name of that variable. So let's simply make our variable as constant. I just write constant. Great. Now let's try to change the value of that variable. As you can see, we had an error. It says this variable cannot be used as an assignment target because it is constant. But the other variables in that package are not constant, so we can still change them. Alright, now it's time to see how we make a package serially reusable. The only thing that we need to do is writing pragma serially reusable right after the is or as keywords, but with a semicolon at the end. Let me show you. I write pragma serially reusable. See that? Pretty simple. Now let's compile and see the effects. Now, as we declared our v salary increase variable as constant, we cannot change it. So let's change our variable v company name. I write v company name is equal to, let's say, Acme. And let me copy that and paste in here. What we did here is we updated the value with Acme text and take the output of that variable. Now let's run and see what happens. As you can see, it is overridden. Why did this happen? I expected that it would print Oracle. So let's run the single print code then. Let me copy that again and paste here and run it. Did you see that? It returned to Oracle. So as soon as our block finishes, it is set to the initial value again. So the changes persist while our call to the server continues. How long our call continues living then? When we run a block of code, whether it is anonymous block or a subprogram, the server call continues until the end keywords. So your changes will persist in your block, but will be returned to its initial status as soon as your block finishes. Means as soon as your call to the server ends. If so, I wonder what happens for the other users. Will that change affect the other users? Let's test it then. Let's copy that code and paste to the My User worksheet. And delete these and write HR prefixes before it. And run the single output code first. As you can see, it is Oracle. Let's run the code block again. As you can see, it is Acme, so it has changed. Now let's run the single output again. As you can see, it returned to Oracle. So I wonder what happens when a user's call continues. For example, what value will my user see while the server call of HR user continues? Since our code is so small, it is not possible to run the other at the same time. But we can sleep our code execution for some seconds. At that time, we can easily run the code in my user. Alright, to do that, we can use the sleep procedure of the dbms lock package. But the HR user does not have the related privilege for that package. So we need to grant that privilege first. To grant that privilege, we need to connect with the SYS user. So let's open up the command line and connect as sysdba. We write SQL plus / and as and sysdba. If you have a problem like that, press enter for some time and write SQL plus SYS / and the password that you have assigned while you are installing your database. It's 123 as you know, and write as sysdba. Semicolon and press enter. Alright, now we can grant. I simply write grant execute on dbms lock to HR. Great, we have the privilege now. So it's time to test. So in the HR worksheet, we simply write dbms output dot dbms lock dot sleep and specify the number of seconds that the program will wait as the parameter. I simply write dbms lock dot sleep, and for the parameter I can say that 20 seconds. Now let's run it. Now our call will wait on the server side for 20 seconds. Now I will run the single dbms output command in the my user worksheet. As you can see, its value is still Oracle, but we have changed it Acme in here. But this is not affected. Even if serially reusable package variables are stored in a pool in SGA, the changes are still kept for each call. So each user will still have their own changes until their block ends. Or in better words, their single call of the server continues. Perfect. Now you know the persistent state of packages with all the details. Before finishing that lecture, I will show you one more example about the cursor usage of packages, because this is an important usage. You may need to use something like that in your work. Alright, now at first, let's remove the pragma serially reusable property from our package and compile it. Because this example will not work with serially reusable packages. Now, you know the sequences, right? Whenever you call the next value from a sequence, it returns the next value, not the same one. But it returns the next value to anyone. I mean, it is not specific for your session. What if you want to make a cursor that returns you the next values whenever you want? For example, you may want to use that cursor by multiple subprograms, and in each call, it will return the next value without starting from the beginning. Can we do that? Yes. But how? First, let's use our cursor in a standard way. What do we do for that? We open our cursor, fetch the next values, and close it at the end. Let's write that then. Let's delete all these and start writing. Declare vemp employees %row type. Our begin keyword and end keywords. Open constants pkg dot cur amps. Let me copy that cursor. Now I fetch constants pkg dot cur amps into v_amps and close our cursor. But before that, let's dbms output something. vamp dot, let's say, first name. Great. Now let's run it. We have a typo here. Identifier vms must be declared. I think it's in here. Let's clear up and run again. As you can see, this is our first employee, Steven. Now let's run it again. It is still Steven. Now, here's the thing. Since our cursor variable lives in our PGA until our session ends, what if we try to use that cursor in another block? Now let's copy paste our code and delete the open and close commands. Let's do it then. With this way, we intend to use the cursor that resides in our PGA. Let's run it then. But we have the invalid cursor error. The reason is we do not have an open cursor. We have closed it after we used that cursor. What if we don't close the cursor? So let's comment the close command in the code above and run it again. Great, we saw Steven again. And we did not close our cursor. So it's still open. So let's run the code below then. See that? Nina. She is the next employee. Let's run that code again then. As you can see, it is the next employee, Lex. The important thing in here is, if we don't close a cursor, whenever we fetch a row from that cursor, it will return the next row, whether it is in the same block or subprogram or not. This is important. You can make a package about that, including both open and close functions that open and close the cursor of that package, and a fetch function that returns you the next value or list of values. So you can use that cursor with a better fashion among the subprograms. Alright, the reason for that state is our cursor is persistent in our PGA until our session leaves. Since your cursor still lives in your session, any call to the next will return the next value, whether it is called from the block that is opened or not. But do not confuse. Even if you don't close the cursor, the other users will have their own instances of that cursor. So their cursor will start from the first employee and iterate only if they fetch a new row. Perfect. Now you know the persistence of the packages in all the details. If I need to sum up, I can say that all the variables and object instances are stored in your PGAs and continue living until your session ends. Your changes do not affect any other user since these variables are private for each session. Besides, if you set a package as serially reusable, the variables and objects are stored in a pool in SGA instead of PGAs. So your changes will be gone as soon as your call to the server ends. Alright, this is the end of this lecture. See you in the next lectures.